So far, our study of trigonometry has focused only on right triangles, and we've learned to find the sine, cosine, and tangent of any of the acute angles, any of the two acute angles in a right triangle. This lesson is going to show you how to define sine, cosine, and tangent for angles 90 degrees or even bigger. So we're going to start by looking at a familiar right triangle. And we're going to focus our attention on this angle, this acute angle right here, somewhat in the center. And we're going to look at this triangle on a coordinate plane. And I'm just going to label a couple of the points on here. So this particular angle can create this right triangle right here. And this coordinates of this point here, I'm just going to call them x, comma, y. And what that means is that this side measures x and this side measures y. In order to find the hypotenuse, we just use the Pythagorean theorem. A squared plus b squared, well in this case the two legs are x and y, should equal that, and we're going to call it r, which stands for radius, because we're actually going to start thinking about these angles as being angles of rotation, and it'll be the radius of a circle. So if you solve for r, you discover that the hypotenuse is the square root of x squared plus y squared. So I'm going to put r right there. And we know that this angle, if I call it alpha, we already know from SOHCAHTOA that the sine of alpha is opposite over hypotenuse, so y over r. And the cosine of alpha is adjacent over hypotenuse, so x over r. And the tangent of alpha is opposite over adjacent, or y over x. Alright, so that's not really anything new. The only thing new is that we've placed the triangle on the coordinate plane with the angle starting at the origin, and we've given it coordinates x and y. But that's the familiar sine, cosine, and tangent of a right triangle. What I'm going to do now is, let's erase this stuff that we've put here in red. And let's now look at an angle that's bigger than 90 degrees. So let's get this triangle out of here, and let's look at an angle that's actually obtuse. We're going to put the angle in what's called standard position, meaning the initial side of the angle is right here, and let's say the terminal side is right here. And so we're looking at this angle, and suppose goes through this point. I'll call it x and y. I'm going to define the trig functions for this obtuse angle exactly like I did in red with the acute angle. The sine of alpha will be y over r. The cosine of alpha will be x over r, and the tangent of alpha will be y over x, and r is again the square root of x squared plus y squared, because we're looking at this length right here, and you could look at this right triangle right here. This would be x, this would be y. Now notice that when you do this, your x coordinate is a negative number. So in this case, if the angle is obtuse, the cosine is actually going to be negative because the x coordinate right here is a negative number. Alright, that's how we define sine, cosine, and tangent for angles bigger than 90 degrees. I'm now going to show you what your homework problems will ask you to do. So you're going to be given problems like this. The terminal side of an angle in standard position passes through -2, -8. I'm going to show you how to find the trig values for that angle. So first, it's kind of useful to draw a picture just to think about what we're saying here. So we have an angle, let me draw the angle in red so it stands out, in standard position, which means it starts here and its terminal side goes through the point -2, -8, which might be down here somewhere. Oops, down here. So that's -2, -8. And the angle we're looking at, like I said, it starts here and it goes all the way around to here. So this is actually bigger than 180 degrees. So here's how we're going to get trig values for that large angle. Well, the first thing to do is to find r, which is the square root of x squared plus y squared, or in this case, the square root of -2 squared plus -8 squared. Remember, when you square negatives, they become positive. So I get the square root of 68, which simplifies because 4 goes into 68 17 times. So that would be 2 square roots of 17. And that is actually the length of this segment from the origin to -2, -8. Now, the sine of the indicated angle is the y coordinate, -8, over 2 root 17. And I'm going to clean that up by dividing out the numerator and denominator by 2, and I get -4 over root 17. And if I rationalize the denominator, I would get -4 root 17 over 17. And then for the cosine of the angle is always the x-coordinate, in this case -2, over the r value, which we got 2 root 17, or -1 over root 17, or -root 17 over 17. And finally, the tangent of the angle is y over x, or -8 over -2, which is 4. Now, if you're wondering where I got, oops, let me get that out of the way there. If you're wondering where I got those, go back to the previous screen. The sine is always y over r, the cosine is always x over r, and the tangent is always y over x. That's how I knew where to put the -8. And the r, remember, I found right here by using the Pythagorean theorem. For your homework, 5 coordinates I give, you're going to find the sine, cosine, and tangent of the angle. You'll do it exactly like I did in the example problem. Have that ready for class next time.